This session is just a short session, really. We're just going to go over the sine, the cosine, and the area rule. Essentially, a very simple section in the maths, and just a couple of things that we have to just sort of go over. Remember, previously, we've always worked with triangles that were 90 degrees. Okay, where we had opposites, we had adjacents, and we had hypotenuse. Okay, now I'm not going to spell it. And we had sine, cosine. Remember, we had theta, sine theta, opposite over, etc. And we had the 90 minus theta up there, if you like. And we went through all of those functions. We went through all of the processes where we could, for example, express the hypotenuse as a vertical and a horizontal. Those of you who do physics, that's components of vectors, right? But now we're going to be moving on. We're going to be moving on to triangles, which in essence, okay, are no longer. Just before we go, okay, remember please that a triangle like that, okay, that's H, right? So we can have areas and things like that with that guy as well, can't we? The perpendicular H like that, or it could have been given in this form, couldn't it? All right, could have given H perpendicular like that for the height. Now, what we're going to do, we're going to see that the 90-degree triangle is going to become a very special case. All right. Just one other little thing that we had. If you remember, we had an angle from the vertical was called the angle of elevation. And an angle down here was called the angle of depression. Okay, depression, a low pressure, it's down. Okay, elevation, well, I suppose you could say he was elevated, he was, high, he was whatever, but that's up to you. Okay, we're going to develop a set of rules around triangles that haven't anymore got 90 degrees associated. The first one of these is called the sine rule. Okay. Now I'm going to use, basically we're just going to put this down. Oops, it doesn't matter. Do that like that. Okay, that is not 90 degrees. Okay, perhaps I should draw it a little more not 90 degrees and make it like so. All right. I'm going to label this triangle A, B, and C. Now opposite, we call that little a, little b, and little c. This is called angle A, angle B, angle C. All right? That's how we notate it, guys. We always take our, where's my, here we go. This is a 90 degree, right? But we always take, if that's A, that's little a. B, little b, C angle, little c on that side, okay? Now, the sine rule is this. The sine rule says the following, okay? It says the sine of angle A divided by the length A. These here are all lengths. They're all lengths. So the length A is equal to the sine of angle B over length B is equal to the sine of angle C over length C. Okay. It's also fair to say that A over sine of angle A is equal to B over sine of angle B, which is C over sine of angle C. Okay. It is the same thing to say that. Right? So basically, all we know is that when we've got a triangle, right, and we're going to go through an example. So it's not a long video, but we're going to go through an example of this. Okay. What have we got? We say, okay, we've got that. That is the sine rule. Okay. The next rule that we've got is going to be the cosine rule. Okay. So let's make a note. The cosine rule. Okay. And I'm going to use the same shape of triangle as I've had before. And he's going to be there. A, B, C, labeled angle, angle, angle C, which means A, B, and C. And no, you could use D, E, F. Doesn't have to be A, B, C's. A doesn't have to be the longest side. It makes absolutely no difference whatsoever. Okay? It's you label it, and you then put in your small A, B, C's, or D, E, F's, or I, J, K. It doesn't matter. P, Q, R's. Right? Doesn't matter. You put in your version of it. Okay, the cosine rule says this. It says a squared is equal to b squared plus c squared minus 2bc cos a. Well, let's just break this down. Okay, a squared, okay, a squared is equal to that squared plus that squared minus 2 times that times the cos of the angle included. All right? This is the included angle. The included angle. Okay? And yes, it is wise to label A, B, C, D or whatever, just so that you remember and write it down on the diagram. Okay? Very easy to just put in the wrong side or whatever, but trust me, just write it down on a diagram, and they are actually quite straightforward. So the cosine rule, okay, is generally, when do we use this, okay? Generally, we use this when we have two sides and the included, that's my awful spelling, and the included angle. Okay, so if you see two sides and this angle, pretty much you're looking at the cosine rule to be used. All right. The last one, number 3, is what we call the area rule. The area rule, very straightforward. It's once again, I am using the same triangle as before. A, B, and C. A, B, C. Angle A, angle B, angle C. Right? The area of triangle A, B, C is equal to a half B, C times sine A. Okay, a half B, C, let's just unpack it. B, C, sine A. So once again, it's the two sides and the included angle. All right, the two sides and the included angle. I could have said the area is also equal to a half A, C, and A and C include angle. Let's just have a look here. I'm using this one and this one, so it must be sine of B. And obviously, it can be a half AB. Right? Half AB, and AB would then be what? Let's just use green. AB, use red. Okay. And I'm using these two now, so it's sine C, correct? That's the included angle, isn't it? All right. So whenever you asked in these, the area or the this or the that, you know straight away. All right. You can pick it up without even blinking. It's a straightforward sort of thing. Let us take a triangle, ABC, AB, included angle. All right, let's have a look. What have I been given here? Okay. Yeah, A, 10, and 15. All right, let's just take this example. example. Here we go. All right. Now, A, B, and they've labeled it like this. So I'm going to say A, B, C, and they've told us that this is 15 centimeters and this is 10 centimeters. Okay, I have done, now they want the length BC. All right, and they tell us this is 110 degrees. All right, and they want the length of BC. Well, they want a length. We have been given a side. Let's just look. We've been given a side, and an included angle. That means cosine rule. So I write down the cosine rule, and the cosine rule tells me that I must do a squared must be equal to b squared plus c squared minus 2bc, okay, cos of A. Let's put it down, is equal to 10 squared plus 15 squared. Squared. Let's take that little thingy out there. 15 squared like that. Excuse me. 15 squared minus 2 times 10 times 15, okay, times cos of 110 degrees. And basically we work all that out and we get A equals 20.68 meters. 0.68 meters. Okay? Centimeters. Okay? So you'd expect it to be longer, wouldn't you? Right? You'd expect it to be longer because the triangle does that. So that's going, A will be the longest side. There's always a little bit of logic to go back and say, hang on, that's it. Okay. Now, let us find angle B and angle C. What do? Well, we say sine of B over B is equal to sine of A over A, don't we? You can't put B and C together because you don't know them. So therefore, sine of B is going to be equal to B sine A over A, which is 10 sine 110 over 20.68. Correct? Which is what we just worked out above. Now, that leaves us then with that B, and that's going to be equal to 0.4544. Okay? If you're not using automatic answer, always go to 4. Therefore, B is going to be equal to 27.03. Okay? Next, we'd go for sine C. Therefore, and I can say sine of C is going to be C sine A over A, which is going to be 15 sine of 110 divided by 20.68, which is going to be 0.6816. And my final answer, therefore, is angle C is going to be arcsine of that is going to be equal to 42.97. Okay, degrees. Now let's check. Let's just hold on, check. Let's sum all angles. So I've got A is 110 degrees. Okay. B was 27.03 degrees plus 42.97 degrees. And my final answer is 180 degrees. Tick, I am correct. There is one little thing that we have to go through. We've got to go through, let's have a look. What is the area of this triangle, shall we? What is the area? Well, the area is going to be a half BC sine A, because these are what I've got. So I say it's a half of 10 times 15 times sine of 110 degrees, which is going to be what? A half of 150 times that is going to be 70.48 units. Now, if they don't tell you, remember, you're going to have to put units squared, right? In this case, it's centimeters squared. Always remember, if they don't give it to you, you're just going to put in the units squared or the units length, right? Here's another example. Here's an example. Here's a triangle A, B, C. Okay. And let's take 10 and 15, right? They say the area of triangle ABC equals 70.48 units squared. Okay. Calculate angle A. Right, so what are they asking us to do? They're asking us calculate this angle here, aren't they? Now they've asked us, this is the included sides, and already they've given area, so therefore we know we're going to be using area is equal to a half BC sine of angle A. Right, that's therefore now, so area 70.48 is equal to a half of 10, 15 sine A. You guys know where this is going, I'm sure. We end up with sine A equals 0.9397. All right, at the end of the day. Now, this is a trig equation. All right, you have to say RA is equal to 70 degrees, right? Therefore, type is sine, right? If it's a sine, my angle A is going to be equal to 70 plus 360 degree K, and A is going to be equal to 180 minus 70 plus 360 degree K. Correct? Therefore, I get two angle A's. One is 70 degrees, and A is equal to 180 minus 70 is 110 degrees. Okay? Why did I drop the K's? Obviously, because in this case, it doesn't count. It's a single triangle. Where does the 70 come from? Well, obviously, if you think about it, it's quite straightforward. I could have a triangle like that with a 10 and a 15, 70 degrees. I can also have a triangle like that, 10 and 15 with 110 degrees. Okay? Sorry, 70 degrees there. Right? Essentially, it's like a pair of scissors, isn't it? You can have a triangle there and a triangle. This is the acute angle, and this is the quadrant 1. Quadrant 1 angle, isn't it? You've got the acute and you've got the quadrant 1 angle, right? So if you are given an area and asked to find an angle, always remember you need to show both. All right? What I'll do is in the exam prep, we'll do some, because you get a whole lot of them where they're linked the one to the one to the one, and you have to go and find, you have to work through a whole bunch of triangles that are, maybe it starts like that and then it goes off there and down over here like that, and they give you lengths and you have to work out that, for example, that is equal to, that length is equal to 2 sine this over cos that, etc. Those I will do in the other side, right? But essentially what you do is, in those there, is you start off where you've got the most info. So if you have the most info in the triangle over here, right, you work the triangle there to find that length. Then you'll use that to find the next lot, and you'll go from there to find the next lot, right? Using the sine and the cosine rule, right? And when you look at what you're asked to prove, look and see if it's got sine in it or cosine. If it's got sine or cosine, you know you're probably going to use the sine and the cosine rule, all right? If it's just sine, then the cosine rule might not be applicable to it, okay? They're not too tough. They really aren't. That brings us to the end effectively of trig. We've got financial maths to go through, and then we've got some probability and some stats. So we're kind of coming towards the end in the fourth term, or the third if you're on a trimester series. It's been great. That's been a tough session for me. I bet it's been tough for you as well. Trig is not easy. Not at this level now. The algebra is probably easier. Even the calculus is easier for those doing AP than the trig, because it's a lot of, you've got to see where you're going with them. But you know what, guys? Keep at it. It is worth it in the end. Trig is a portion of it. It's a big portion of it. Master it, and you know what? You're flying. Cheers. Keep well. Bye.